So 13. So the function f, so the graph is of f. G is a function represented by the integral. So g is the integral of f from -6 to x. Okay. Write the equation of the tangent line. All right, so that's what they're asking. The equation of the tangent line to the graph of g at x equals 9. Okay, so they're looking for an equation. So I put the y minus y1 equals m, x minus x1. We have to fill out those things. Those are the three things we need to fill out for the equation, to fill out an equation of a line. Okay? So if we need an equation of a line, we need three things. I need an x-coordinate, I need a y-coordinate, and I need a slope. An x-coordinate, a y-coordinate, and a slope. Three things. Which of them is probably the easiest to find? Which one's probably the easiest? The x-coordinate. They give it to you, right? X equals 9. Perfect. Let's write that in. Right there. Okay. This is a 3-point question. 1 point is already done. 1 point's given. Okay, so now we need a y-coordinate, and I need a slope. Okay? To get a slope, what do I need to do? Anytime you need a slope, what are you always 100% going to need? You're always going to need what? The derivative, right? And in this case, they want the equation to be tangent to g. So I need g prime, right? So to get the slope, I need g prime. What is g prime equal to? The graph, yeah, f of x. If g is the integral of the graph, g prime is the actual graph. Okay. So I need g prime at 9, which is the same as f of 9. They're both the same. G prime of 9, f of 9, they're both the same. They're going to give me the same number. How do I find either of those guys? Keep going. At, there you go. The graph is f, right? F of 9 means the y-coordinate at 9. The y-coordinate at 9 looks like it's 3. So g prime of 9 is 3. That's the slope. Okay. Last thing is the y-coordinate. The y-coordinate, right? How do I get the y-coordinate? We've done this before, just not with an integral, but we've done it before. How do I get the y-coordinate for x equals 9?
May I just go out on a limb here and say plug in 9 for x for g of x? I'm not sure.
Well, if you had an equation, let's say we had an equation. G of x equals x squared plus 4, right? To get the y-coordinate, we would plug in the x to there, right? And get a y. We're going to do the same thing, except it's just an integral. So g of 9 equals -6 to 9 f of t dt. Plug in 9. So now to find g of 9, which is the y-coordinate, we need to find the area under the curve from -6 to 9. Okay? Of the graph. -6 is right here. +9 is right here. So we have to find the area, all of this area. That area, and this area. And that'll be our y. Well, the first part, the pink part on mine looks like it's a triangle. So base times height divided by 2. So it looks like it's from -6 to 2, so it looks like this is 8. The height looks like it's 2. So 8 times 2 divided by 2 is 8. But it's underneath, so it's going to be -8. So -8 plus. And then the green part, which is above the x-axis, looks like it's just a trapezoid. Okay, so base 1 plus base 2 times the height divided by 2. So base 1 is, what is that, 3? Plus base 2, which is 7, times the height, 3, divided by 2. So 10 times 3 divided by 2, 15. Yep. -8 plus 15 is +7. That's the y coordinate. So when x is 9, y, or g of 9, is going to be 7. We put it up here. We're done. As far as you need to go. It's an equation. Didn't say what type of equation, just said an equation. Okay? All right, I want to do number 15. I'm going to skip 14 for right now because 14 is the same type of problem we just did. I want to do 15, though, because 15's, we haven't done one like this. Okay? Okay, the areas of the region bounded by the graph of f and the x-axis are labeled in the figure below. So they've already done the area. They've already figured out area. This area here is 12. This area here is 14. This area down here is -13. Okay. So let the equation g of x, or let the equation of g by the equation, defined by the equation g of x is equal to the integral from x to 8 to x f of t dt. What is the minimum value of g? So when you hear minimum value, because that's what we're looking for, the minimum value, what should we automatically think when we see or hear minimum value?
Two things. It changes sign, but it changes sign from is it negative to positive, so to speak?
What changes signs?
X changes sign or F changes sign.
You're getting there. You're almost there.
The function changes sign.
No. What changes signs? You're close. Minimum. When we see the word minimum, what should you automatically, your brain, go to in this class? When you see the word minimum, doesn't matter where it is, you should always think, we're going to have to find the first derivative, right? We're going to have to find the first derivative. Now, it's not saying a relative. It didn't say relative minimum. So we're not going to do it that way. What it's asking for is the absolute minimum. The absolute minimum. We've done this before. So when it's an absolute minimum, you have to find the derivative. So you need the derivative. So what's the derivative going to be? F of x. Then what do we do? That's the derivative. What do we do with the derivative? What do we do with the derivative to find the minimum?
Set it equal to 0.
Set it equal to 0. When is f of x or g of g prime, when is that going to equal 0? How do we know when that guy's going to equal 0?
Find the y coordinate at x equals 0. Then I could be wrong.
So what? So how do we know when f of x equals 0? How do we know when f of x equals 0? Well, first of all, where is f of x?
F of x is the graph.
Okay. So how do we know when the graph equals 0? When it crosses, when it touches when the y value is 0. Okay. The y value is 0 here. The y value is 0 here. The y value is 0 here and 0 there. Okay. So the y values are 0 at -6, -1, 4, and 8. One of those is going to be the absolute minimum. They're all minimums. Oh, they're all either minimums or maximums, relative or absolute. But we have to figure out which one of those guys, because on a multiple choice test, there's your A, B, C, and D. So you have to figure out which of those is the absolute minimum. The absolute minimum. So what do we do now? How do we find the absolute minimum? I don't care if they're relative maximums or minimums. I don't care. I need to know which one of those guys is the lowest, the absolute lowest. How do I do that? Mm-hmm. Close. What do I do? I make a table, right? X, g of x. I want to include all of my points, -6, -1, 4, and 8. And I want to make sure that my endpoints are there too. -6 and 8, they're already there. So if they weren't there, I need to include them. Okay, so now we're going to plug it in. So how do I plug it in? How do I find g of -6? How do I find g of -1? How do I find g of 4? How do I find g of 8? How do I find those? Plug them into the original equation, right? Okay, so this one's going to be from 8 to -6 f of t. This one's going to be from 8 to -1 f of t. This one's going to be from 8 to 4 f of t. And this one's going to be from 8 to 8 f of t. Whichever of those guys gives you the smallest number, you got a winner. So you have to find the area under the curve from 8 to -6. 8 to -6. Well, 8 to -6 is not in the correct order, so you got to flip those. So -1 times -6 to 8. So I already have the area. I just got to add them up. From -6 to 8, it's 12 plus 20 plus 14 plus -13. From -6 to 8 is 12 plus 14 is 26. Plus negative 13 is 13. But it has a negative 1 in front. So my answer is actually going to be negative 13. The next one's the same thing, except now it's from 8 to negative 1. Well, 8 to negative 1, you have to flip those again. So it's really from negative 1 to 8. So from negative 1 to 8, you have 14 plus negative 13, which is 1. Change the sign to negative 1. From 8 to 4, you got to do the same thing. So it's going to be this area here from 4 to 8. So 13, change the sign, positive 13. The last one is from 8 to 8. That's just 0. So you look at those, whichever one's the smallest is the absolute minimum. It looks like negative 6. So the absolute minimum is negative 13. Negative 13 is the absolute minimum for that guy there. It's the smallest y value out of all those guys who are either, all of those guys are going to be absolute minimums, absolute maximums, relative maximums, relative minimums. So absolute max, they don't ask us this, but absolute max is 13. And then negative 1 and 8, those are probably just relative maximums or minimums. But they only ask us for the absolute, so we just want the smallest. Okay? So the ones we haven't done are just repeats of what we did earlier. And they're also on your worksheet. So I'm going to let you guys work on the worksheet. I'll do these right now while you guys are working on those. So I'll post them in the notes. I'll finish the notes out, but I think it's more beneficial for you guys to work on that. There's not a lot of room on there, so if you want to do it on a separate sheet of paper, you can. In order for me to fit all the problems on one page, front and back,